we have observed a particular kind of shape and coordination number also. The first shape that we can take here is linear. In linear shape, we have to see that the particular compound should be stable one. As for an example, you can see here CO2. CO2 is an example of linear molecule. It has a bond angle of 180 degrees. Along with it, we can take the example of HCl, HBr and HF also. Right? Next is trigonal planar. In this shape, all the molecules, like mainly 3 different atoms, combines with the central atom and they form a trigonal shape, but it's a planar one. We can take the example of BF3, we can take the example of SO3 here. These are very common examples of trigonal planar shape. Here the bond angle is generally 120 degrees, right? Next is tetrahedral shape. Tetrahedral shapes best example is CH4. Methane shows the example of tetrahedral. Here the bond angle is generally 109 degrees, right? Next shape is octahedral. In octahedral, we can take the example of SF6. The central atom will be attached with another 6 atoms here. As you can see in the image, SF6 has the bond angle of 90 degrees. So as octahedral will also have 90 degrees bond angle, right? So in this manner we can see that how the attachment of the atom changes the shape of the molecule. So depending upon that, their bond angle will be different, and as the bond angle changes, along with it, their shape also changes. Now, our next topic is hard and soft acid and bases. What is the meaning of this HSAB theory? This theory is generally referred as HSAB theory. So, we can have our Lewis bases, or Lewis bases generally can be divided into 2 different categories, right? Number 1, hard bases, and number 2, soft bases. So what is the difference between hard bases and soft bases? Let's observe it here. Hard bases contains small, relatively non-polarizable donor atoms. So bases are generally donors as they contain a higher number of electrons. Okay. While soft bases contain larger and relatively polarizable donor atoms. Again, remember it particularly, bases are generally donors and acids are acceptors. Remember it properly, okay? So, the metal ions with the highest affinities for hard bases are hard acids, okay? Generally, it has been observed that hard bases combines with hard acids as well as soft bases combines with soft acids, right? Their affinity, their match is very perfect. Whereas the metal ions with the highest affinity for soft bases are soft acids. So in this manner we can say that soft attaches with the soft while hard attaches with the harder one, right? Now let's take a look at another one. Let's take a look at the examples here. Let's take an example of hard acids and soft acids first. So H plus, Li plus, Na plus, K plus, Ca and Mg plus. These are considered as hard acids. While another one soft acids. So Cu plus, Ag plus, Au plus, Pt plus as well as Hg plus. They are considered as soft acids.